AI this semester. So we are very happy to have the wrap up of the week of the semester with you. Our pleasure, actually, because you introduced us to a lot of new things. This morning, I contacted Ibu Suning, and she is the director of learning and she was part in the Kemenristek Dikti. And she said that, oh yeah, you taught us about LMS 15, 20 years ago, 20 years ago.
Oh, yeah.
Yeah.
Quite a long time ago.
Yes, yeah, but you're very strong and look very fresh today. Thank you so
Yeah,
much.
I'm very fine.
Yes, yeah. So we sort of like having a reunion today. Thank you, Prof. Are. I'm very happy. So you are still in Saga. Where do you live now?
Yeah, I'm living in Saga.
You still live in Saga. Right? Yes, yes.
And working at the 6 different universities in Japan.
I see. Okay. Anything in Tokyo?
No. The surrounding area.
Okay, right.
Yeah, neighboring prefecture.
Oh, right. Yes, yes.
I'm still teaching. I have a lecture course.
Oh, right. What course? The name of the course now?
Artificial intelligence.
Yes.
Exercise of the artificial intelligence and metaverse.
Metaverse also. Reality, right? Wow.
Currently, my favorite subject to teach is that artificial intelligence.
I see. Yes, yes, it's very new, and your talk today is very state of the art because it just started from June. Everyone talking about this third case of AI. So yeah, so we are very happy to discuss this with you because actually you have been having a long-term relationship with Indonesian education. So today, because of you, I contacted many of the alumni. Hopefully they can be here. Yes.
Now, how about your major subject?
I'm teaching this also. Actually, our research group is called X Intelletech, which is intelligent technology. I was starting from computer network programming and protocol engineering. I teach NS3 still until now for the simulation. And
I see.
and also now AI, software engineering also, of course, with 5 programming and AI because it's the state of the art. We have to know. So something that you are talking to, the discussion today will be a great benefit for us to wrap up the day. And this is not just from University of Indonesia, but also I invite friends from Indonesian AI Society. So
I see.
anyone that is interested could come and when they have time. So I don't know. It is starting with the hoping that we can reunite, for celebrating your talk end of this year with us. So thank you so much.
So you must know the Python code.
Yeah.
Python or PyTorch.
Yes, yeah, we are using that for the programming, but I'm not teaching programming in detail. It's software engineering, the whole software engineering life cycle from the beginning, making sure that they can be started up with all the starting from the design to the documentation, testing, and all the software engineering life cycle to the maintenance version.
I see.
Yeah.
Do you have position of the adjunct professor
Here?
at your university?
Yes, yes. Yeah. We have friends from National Taiwan of University of Science and Technology, and I'm also a adjunct professor there in NTUST Taiwan. Yeah, but we have long-standing exchange student for the last 15 years. So every year, 10 students from us goes there for summer program, and also eventually do some master, and also eventually work in TSMC and some companies in Taiwan. So this is
I see.
already 15 years close
I see.
relationship. Yeah. Mhm.
Yeah.
Yeah, it takes some time, but I know that you have a lot of friends in Indonesia, but I'm very honored that you contacted me. Thank you so
Yeah.
much.
Because I found your name
Where did you find it? In in LinkedIn?
on LinkedIn.
Okay,
You
yeah,
know,
yeah.
that's why I contacted with you.
Thank you. We have so many of us now, and yeah, I think many of the alumni of your program is now really well heading the Indonesian IT sector in terms of educational sector.
I see. Oh, the time
Yes, it's
is now.
10 o'clock
You
already.
better to
Yes, so
begin with
yes,
your introduction.
yes, I will introduce. Well, 1 second. Right. Shall we start now? Right.
Yeah, sure.
Good morning, everyone. Welcome to our today's guest lecture on AI-powered information retrieval with MCP RAG, which will be presented by Professor Kohei from the University of Saga University in Japan. Well, over the past years, many of us realized that we have uh, the phases of AI from the generative AI to large language model, and also we have agents and also agentic AI, and that is why today the in academia and enterprise system, many of us start to implement agentic AI, and also that's where MCP RAG comes in, combining multi-agent intelligence with structured, controlled access to data and tools. So today we are very honored to learn directly from Professor Kohei. He has been a long-standing leader in intelligent systems and international academics collaboration, and he has many friends in Indonesia because I think the program of the JICA program that we was invited to JICA and to University of Saga 20 years ago, lasted for like 5 years. So I'm very happy to introduce you to call Professor Kohei Array. Professor Array, the floor is yours.
Okay.
Can you on your video? Is it okay?
Good morning, everyone.
Morning.
I'm Kohei of Saga University. At the Lily San's, San means Mr., Doctor, Mrs., and Miss everything. Lily San introduced me. I was a leader of the project ICT technology for the education, in particular dedicated to the Indonesia. Ah, almost 20 years ago. And since then, I am making the effort to progress the AI technology to the education. And this time, I would talk the AI-powered information retrieval, in particular for the MCP lag. Do you know the MCP? Didi-san, you know the MCP stand for?
Yes, multicultural protocol,
Oh, yeah.
which
And the lag, it stand for?
language model, LLM.
Okay.
The RAG is retrieve augmented generation.
Oh, I see.
Yes.
And I created the MCP lag. And the MCP lag, most of the Japanese company, um, the local governments are creating their own MCP lag. So also previously I developed the my MCP lag in my laboratory so that the this course I will start with the what is the information retrieval, followed by the MCP, and then lag, and the AI-powered MCP lag. Can you see this?
Yes, very clear. Thank you.
Okay. Now this is the poster that Lily-san created this poster for my lecture, AI-powered information retrieval with MCP lag, multi-agent systems. This year, Data Innovation Summit was held. This Data Innovation 2025 is European's largest annual event dedicated to the data, artificial intelligence, and analytics innovation, which was held in Stockholm, Sweden. It has a direct and influential relationship with the lag. That's why today's topic must be lag. And in the Data Innovation Summit, they discuss the applied data innovation, data science, big data analysis, social media data, machine learning, applied AI, generative AI, data management, data engineering, architecture, database, and IoT, in particular, AI-driven transformation that would help to retrieve the information. That's why today's topic is the AI-powered information retrieval, lag. The role in the Data Innovation 2025 is highlighting the lag frameworks as essential for grounding LLM, large language models, with enterprise data. So lag-based use cases are plenty of. The cases are introduced and discuss the efficiency or effectiveness of the lag in the enterprise company or local government and other societies. Information retrieval is the science of the searching for the information in document, searching for documents themselves, and also searching for metadata, data of data that describe the document. Information retrieval systems have evolved with the integration of the artificial intelligence, especially deep learning and the neural network model architectures. Nowadays, MCP RAG is getting more popular in every country in the world. Here I have the AI information search systems. Here the users submit a query, search query to the AI search engine, and search engine ask access to the data sources through the web from the database with the natural language. This is essential AI information search systems. The key features of the AI search is the high precision of the search through the semantic understanding and the context-aware result ranking, integrated information retrieval from the multiple sources. Here's the evolution of the information retrieval systems starting from the 1960s. Boolean search, the main topics, and the year 1970s, TF-IDF, vector space. This is the traditional information retrieval. And 90s, BM25, page ranking is the main topics in the information retrieval systems, and deep learning and transformers and large language models, so that the traditional IR, information retrieval, rely on exact keyword matching and statistics, followed by modern artificial intelligence and machine learning approaches, understand semantic and context so that we can retrieve information by using our natural language. Neural networks revolutionize how we represent and match the text. So by using the network architecture, we can retrieve the information. This is the classical information retrieval foundations. Bag of word, bow model is a famous one. Early information retrieval model. In the data space, vectorized space can be retrieved with the Boolean algorithms, and probabilistics models are created to access to the most appropriate information. Most famous functionality of the ranking is that BM25. These tools are commonly used for the classical information retrieval. And the embodied index, this one here is the ranking, and the embodied index is a reverse word of the indexing, efficient data structure for fast document information retrieval based on the term of the occurrence. So occurrence is a keyword for the information retrieval in the classical model. This one here is a bow, bag of word model, and the ranking function. Here is an example. The cat sat on the mat. And this sentence The appeared 2 times. Cat 1, sat 1, on 1, and mat 1. So most frequent word is that. A text representation method that treats document as an ordered collection of the word. Unordered. They don't care about the order. Ignore the grammar, word order, and the sentence structure. They don't care. Focus only the word frequency and the represents. That presence. That is the bag of the word model. So that the high rank word in this case is a that, followed by cat, sat, on, mat. Example of the bow model, word order is Rust. Learning machine would be identical. Only a frequency matters for the matching and the ranking. So in this example, machine learning is powerful. Machine learning transforms data so that the bold representation, machine appeared 2 times, learning appeared 2 times, and is powerful, transforms data appears just one. Term of the frequency is calculated by, with this equation, count of the term T in document D. That's why it TF is a function of the T and D. And normalized TF can be represented by this equation, count T D over total terms in D. This is the equation of the normalized TF. Higher frequency indicates higher importance in the document. This is the principle of the term frequency based information retrieval. Inverse document frequency can be represented by this equation. df n divided by df. In this case, n denotes the total document. df denotes document containing term T, so that it's how rare the word appeared. How rare. So that this rareness is important for the IDF representation. Rare term get higher IDF score. So like the and appears many times. Such many times appear the words are not important for the IDF representation. So that by combining both TF and the IDF, ranking mechanism can be created. TF dash IDF can be expressed by this equation multiplied by IDF. A document score for query score can be represented by this equation. for all term T in query Q. So a query Q comes in, and the TF-IDF can be calculated, and summation of all these TF-IDF is a score. So a high score of the document would be the answer to the query Q. That is the ranking function and the old fashion of the information retrieval. BM25 is a famous information retrieval systems, ranking systems, state-of-the-art probabilistic ranking function. BM25 can be represented by this equation. This term is very similar to the previous TF-IDF, and other than that, this equation is normalized by these terms. Key parameters of this equation is the K1 here, control term frequency saturation, and the B parameters of B is that control document length normalization, and that prevents over rewarding long document or repeated terms. That's why BM25 information retrieval systems is superior to the old-fashioned of the TF-IDF. Nowadays, artificial intelligence and machine learning is used for the information retrieval. First one is the learning to rank, LTR, query, document, and their interactions, page ranking, term frequencies, user clicks. These are information of the source of the how to retrieve the information. Machine learning model, there are so many. Logistic regression, boosted trees, gradient boosting, such and such, and neural network architecture. And the embeddings of the word to Beck is a famous one. So if I have the word can be created vector, converted to a vector, it's easy to use the word to Beck. And grow vec and the fast text, which allow us to embed, vectorize the word. So query is a word can be converted to the vector, and data source has the vectorized data. So we can calculate the similarity between the query vector and the database vector. And the contextual embedding, this is the statics. But contextual embedding, there are so many famous models like BERT, Lovert, A, and the GPT. Context-dependent representations can be done with the BERT and the Lovert A, Roberta, and GPT. Traditional versus neural information retrieval is a very simple compared to both. Traditional keyword matching is a major, and the semantic matching is a major for the neural AI and machine learning. Statistical feature used for the traditional IR. On the other hand, neural IR uses the learned representations. So a learning model, if we create, then we can retrieve the information in the efficient way. Extract a term overlap required, but neural IR technology allows us to understand synopsis and the context. No semantic understanding for the traditional IR. On the other hand, captured meaning can be treated with the neural IR. Fast but limited, not so accurate, but more accurate, but slower. But once we create a learning model, it's getting fast. The word embedding, as I mentioned before, the word to back is the famous one, Grove in the fast text. Here I have the one of the example, word king can be converted to vector. So in nth dimensional vector, we can convert it from the word king. Similar word has a similar vector. That's why we can compare both vector and vector in the query, in the database. We can find the most similar vectors. Advantage of the word embedding captures semantic relationship, king minus man plus women nearly equal to queen. But there is a limitation, one vector per word, no context sensitivity at all. That's why merit and demerit are there in the word embedding. Neural ranking model, deep learning for relevance scoring. Here I have the input text query, neural network, feature learning, relevance score, ranking output. So one of the merits of the AI-powered information retrieval is that not only one candidate, but also the several candidates can be represented from the AI-powered information retrieval systems with the ranking, rating. Here I have the DSSM, stand for Deep Semantic Similarity Model. On the other hand, kernel-based neural ranking, KNRM, that are two famous models. And other than that, deep neural network for ranking, and match pyramid, hierarchical matching network. These four are famous ranking model. BART model is a famous large language model in transformers, revolutionary architecture. In the year 2018, self-attention mechanisms enable contextual understanding of language. Contextual embedding can be done, pre-training and fine-tuning. So once we create the trained model, learned model, then we can add some fine-tuning. And bidirectional context looks at the entire sentence not just left to right, right to left is okay. In this era, BERT, not only BERT, but also Robota T5 GPT are created and used for the information retrieval. Dense retrieval systems query to encode to vector, document, encode, and vector. So uh, with this the similarity matching, we can retrieve by using the query and document in the database into dense vector embeddings, retrieved by similarity between both embedding space. So cosine similarity, that means that there are, if let me assume that there are two vectors, cosine theta represents to the similarity of the vectors, similarity of the query and document. You got this one here, cosine theta. That's why hybrid search architecture there is. The user query, dense search, and the BM25 search, and the fusion and the re-ranking. These combination of the traditional lexical matching with the neural semantic search, both can be combined together for the fusion of the re-ranking systems. Learning to rank. This one here is the famous retrieval systems. Machine learning model learn optimal ranking from the trained data. Three main approaches: pointwise, pairwise, and listwise. Real-world applications. We can use the BERT for their web search. Query understanding can be done. E-commerce, Amazon, eBay use neural ranking for product search. Enterprise search, Elasticsearch, Sora integrated dense retrieval, and the question and answering systems, ChatGPT, transform, encoding, and decoding. Claude, use a retrieval augmented generation. RAG. This is a RAG. And the recommendation systems, Amazon recommendation systems, all the e-commerce sites have their recommendation systems. We can gather the information from the users with query, preferences, and the characteristics of the users can be retrieved by the keyword. Then such as e-commerce site recommend such as specific users. You would like to retrieve this one. Such a recommendation can be done with the recommendation system. YouTube, Netflix, by the way, Netflix create your own, the Netflix own movie content by using the more than 10 of the keyword. They create script for the movie and create the background music, create the voice. Then finally, the Netflix original movies by using the user's preference. Multimodal search, text, image, video. So we can ask the information, put the query with text, with image, with video, some others. Voices, the personalized retrieval can be done. That is real-world application of the neural information systems. Here I have the challenges in neural information retrieval. Computational cost, challengeable. And the latency, there is a latency, delay. Training data need the large amounts of the leveled relevance data. Interpretability. Neural network is a kind of black box. The other day, I published a paper dealing with the white boxing. So we can keep the accountability of the logic in the neural network. But still, we do have the problem on the black box problem. How to debug index size, dense vector required more storage. So a huge storage we need to create the neural information retrieval. And here I have the solutions. One, model compression, caching, approximate search, hybrid systems. These four approaches are now working on. Key takeaway from this lecture. One of the takeaway is that evolution from keyword matching to semantic understanding. Word embedding was the foundation for neural IR systems. Transformers, revolutionary architecture for context understanding. Dense retrieval, semantic search, and embedding space. Hybrid approach, combining traditional and neural methods, and learning to ranking systems. We can create the most appropriate ranking system by using machine learning models. In the future, the multimodal systems, personalized systems, and the conversational search can be done. Conversational search is now available. Neural information retrieval, interaction-focused model, convolution neural network. I'm making the lecture on the convolution neural network and the R-CNN and fast RCNN, fast CNN, and the mask RCNN, something like that, some others. Capture local patterns and proximity relationships between query and document, and the complex interaction between the all pairs of the tokens and queries and document, and input both query and document together into transformer, namely BERT did it. And the representation focus model data encoder and data independently encode a query and document into a dense vector. And the vector search and cosine theta is one of the vector search, nearest neighbor search in a high dimensional embedding spaces. AI-powered information retrieval. Here I have the BERT T5 GPT, and the machine learning use the information retrieval, LangNet, and the Lambda Mart. Deep learning uses information retrieval, convolution neural networks, transformers, and semantic search, dense passage retrieval. And today, I will talk about the RAG, retrieval augmented generation, and the OpenAI GPT research. Natural language processing. We would like to retrieve the information by using natural language, voice, so that we need process the natural language. BERT allows, T5 allows, GPT allows to process the natural language and create, once we create large language model, then we can retrieve the information by using our natural language. BERT is favored for understanding context, GPT for generating the fluent text, and T5 offer the most flexibility by handling any text in, text out task. BERT stands for bidirectional encoder representations from transformers and transformer encoder only. Whereas the other decoder systems, but BERT allows us to encode something. And BERT is pre-trained models. So already the LLM are in the BERT systems. T5 stands for text-to-text transfer transformer. TTTTT. That's why T5 treats every natural language processing problem is that text-to-text, how to transform the text from the text. Use a full encoder decoder transformer. So a BERT has a only encoder, but a T5 has the encoder and decoder, maximizing its versatility. That is T5 specifications. GPT, generative pre-trained transformer, stand for excel at open-ended text generation, summarization, and dialogues. Use a transformer decoder only. That's why the GPT has a transformer decoder. The comparison among the three, BERT, GPT, and T5, is the following. BERT has an encoder. GPT has a decoder only. T5 has an encoder and decoder. Best at understanding, best at generation for GPT for both T5. So masked language modeling is about next word prediction generation. So GPT has the capability most powerful capability for the next word prediction. Text-to-text conversion, transform, transfer. So T5 allows us to translate the natural language because it has an encoder and decoder. Future trend of the AI-powered information retrieval. First one is the old-fashioned. Now the information retrieval has a limitation, struggles with the ambiguity. For instance, Java could mean the coffee or a programming language, Java programming language, but coffee, Java coffee, I prefer. And the AI revolution, large language model and transformer-based architecture is moving toward keyword with the more intuitive, human-like search experience, such as EX is very important for the future AI-powered information retrieval. Trend 1, retrieval augmented generation lab. How it works. Generation of LLM then synthesize this retrieval information into coherent, context-aware answer by using the natural language. We can retrieve the information with the lab. Key benefit is that reduce the hallucination. Don't tell a lie. Example, the lab system pulls real-time information from a trusted news database. That's why. Trend 2, multimodal and conversational search. Other than the RAG, we can retrieve the information by using multimodal means text, image, video, and audio. Conversational search need the high speed of the interpretation. Trend 3 is that semantic search and knowledge graphs. Semantic search means the voice input with the natural language, understand the meaning of the query, and the most appropriate answer will be extracted from the database and output. And key G stands for knowledge graph. If the knowledge-based system is created, and then such a knowledge can be used for information retrieval, the semantic search can be done. Combining LLMs with the KG, knowledge graph. So nowadays, long chain, and the long graph, long graph create allow us to use the knowledge graph. And if you create LLM combined together, then semantic search can be done with the knowledge base. Example, knowledge graph can resolve complex query. So sometimes query is not easy to understand, but with by using the knowledge graph, it can translate more easily. This slide shows what the semantic search is. Here I have the different aspects of the dyeing of textile fabrics can be converted to the vector. Here I have the vector 1, 2, 3, 4, and this query vector compared to these orange dots of the answer. This is the semantic search. Starting from the prompt, it's transformed into a vector embedding and compared with the vector embedded in the database, orange dot, and returned as the most similar document. In this case, this one here is the most nearest document. So against this blue dot of the query, orange, this one, must be a most appropriate answer to the query. Trend 4, proactive and predictive retrieval. So retrieve needs the prediction and the proactives, personalized using location, history, and preferences. In this case, preferences is most important for the proactive and predictive. So user put the query again and again and again. And then the AI systems understand the user's preference, integration of the real-time data. Example, an AI assist could proactively summarize relevant financial news. Now, from now on, you will have the introduction of the RAG, integrating retrieval mechanisms into a generative model. That's why retrieve, augmented generation, RAG. Incorporating the external information into a generation context. Here I have the simple example of the RAG. This is an example of the query. Who is the president of the US? Retriever or Wikipedia, Joe Biden, nowadays, 47, the president is Trump, Donald Trump. But this slide showed the previous one, Joe Biden, is 46 and the current president of the United States. Assumed office in January 20th, year 2021. This is the answer. In this case, generator output the answer, Joe Biden. This is an example. And the user query, do you support international calling? And step 2, search for the nearest document. 3, retrieve the context. 4, response. So it's a common problem with the search and retrieval systems. MCP, by the way, turned out the MCP is the most popular in the world. Model. This one here is the just a protocol, host agent with LLM, client MCP, agent and client, not MCP servers, knowledge base. Here I have the user, here the LLM, and knowledge base systems. It's a database. It's called MCP server, knowledge base systems. And here the MCP client user's query can be converted to, for instance, SQL command to retrieve the knowledge base and the MCP server and find the most appropriate answer and put the answer to the client MCP and LLM translate from the database to natural language and output to the users with a natural language. Here the generative RAG architecture. First, user asks the information and the augmentation can be done with the RAG and augment the input text for LLM. LLM translate from the user's natural language to the embedded vector and generate, find out the data in the database, knowledge base, generate output, language model can translate from the vector to natural language and output the answer in the form of the natural language. Core concept of the RAG is a static and may become outdated, and the information retrieval mechanisms that fetch relevant up-to-date data from the external sources, MCP enhancing this capability. That's why I recommend you to use the MCP RAG, enable to retrieve both structured and unstructured data. There are two kinds of data in the database. One is the structured data, the other one is the unstructured data.
Gabung sama teman-teman di sana. Terus aku klik Prof. Oh iya yang itu ya.
Don't
RAG.
bother me.
Rencana habis lulus saya mau bikin develop
Don't
itu.
bother me.
Jangan ganggu.
Bikin LLM sendiri.
Silence, please.
Saya di bisnis lagi bikin
Mute,
kan
please.
agent kan. Saya risetnya Prof sekarang di situ semua. Walaupun saya udah lalu mau saya ambil udah
Key component of the RAG is embedding the vectorized retrieval, the system search the vector database to retrieve the most relevant information or the knowledge and convert it to the vectors and the augmentation. Prompt engineering technology augment the input, provide additional context for the LLM, generate LLM the response, fine-tune internal proprietary data, tokenizer, embedded data. Here the user query, here comes query text. And the retrieval is also important. Techniques used hybrid search, combined semantic, and the keyword approach. Both the system retrieve lead, policy document, and personal record. What is my annual leave balance? Such this query comes in, then the system retrieve the leave policy document and personal record. The augmentation will be done to enhance the capability of the information retrieval and generate the output answer by using LLM maintenance and updating the MCP RAG can be clever and clever with the user's query. Regularly updated. Data collection need the RAG, information extraction, chunking. Chunking means the query have to be chunked with the small pieces. And the embedding, that is means the vectorized. Indexing and search retrieval can be done with the knowledge base, and the LLM translate natural language to vector, vector to natural language. Challenges conservation of the RAG, data quality, very important, availability, integration complexity, computational cost, and resources, privacy, ethical issues, scalability challenges. And the user put the query, database, retrieval, LLM responses, creation. Here I have the example. I created this RAG systems by using the Streamlit React Python code fast API. We create the prototyping of the user interface, web interface with Python code of the Streamlit. Final RAG system, React, and the fast API backend we need to create a fast API, React API. And the database retrieval, I used SQLite. In this case, the knowledge base is not so huge, very small. That's why SQLite would be enough. And the final RAG system, MySQL, created. Chroma database is a famous one. It's easy to retrieve the relational database. And the generation of the response with the LLM, ChatGPT 3.5 Turbo, ChatGPT 4.0. And here I have the, sorry about the Japanese character. Here the document, database, and long chain I used. And model calling can be done with the OpenAI, and the query comes in to this RAG systems, and the answer is outputted to the users. RAG, MySQL plus MCP server. It's this combination of the database search, agent serving, users, Chroma DB, LLM prompt, vector DB retrieval, generation of the response can be done with the Chroma. Text to SQL. If you use a natural language as a query, then the text to SQL software tools allow us to convert to SQL command So it's very easy to use the such this RAG. Machine learning method train the model by using the language and the SQL pair data can be created so that the learned model we already created. And technological trend LLM is the combined together text to SQL uses using the chat GPT, Claude, GPT-5, nowadays GPT 5.2. Model can understand the complex new natural language and generate more accurate SQL query. Few shot learning, this is the technology, prompt technology, and chain of thought, cognitive interface, inference, and multimodal support we created. And here's one example of the framework using the Anchor board. Anchor board is a machine company creating the such this part by using text to SQL, MySQL, select, form, accessories, wireframe, underbar ID in 1, 2, and part name like framework. Now this is the query to the database with the SQL command. But this one here, framework using Anchor board, it's a natural language of the query. If we input such this natural language query, then text to SQL converted to the SQL command. And the response is here. Sorry for the Japanese again, but most appropriate output comes out from the MCP lab. Here the Streamlit web applications. The database agent, we can create the here the prompt in Japanese. And if you click this radio button, then you can find the output. Please take a look at this video. Create the database, is searching the database, and create output. Like this. So that we can retrieve the information from the knowledge base by using the natural language. User question framework using Anchor board. This one here is the answer by using text to SQL. You can create some SQL command. In this case, Streamlit is used for the web application creation, but implementation of the complex user interface is not easy. So limited flexibility and page transitions. So PAM performance is limited. So we change to the framework integration, React for front-end JavaScript, and the fast API for the backend with Python code, and create multi-agent MCP RAG. MCP stands for Model Context Protocol. Here I have the three kind of MCP. One is MCP host, LLM, MCP client, control MCP server, and MCP servers. That is a database. MCP protocol. MCP is a protocol required for AI agent. AI agent can perform multiple processes in response to users' request. MCP is a kind of the protocol and provide these agent with the tools and knowledges as the SaaS used by AI agents. By using the MCP protocol from the MCP client, we can retrieve the data of the calendar, notion of the information, and box external tools of the data. We can retrieve all these databases by using MCP protocol. Same thing for this, so that this one here is just a Type-C connector. Allow us to connect from the other LLM. We can connect the same data server. So MCP host, by using the cloud desktop IDE agent application and the MCP client, cloud can be done. LangChain can be used for MCP client. For the MCP servers, SQLite MCP server is easy. Local data source, SQLite, JSON file, remote services, Notion API, Slack API, some others, so that we can create the MCP RAG easily. Here I have one of the example from the users through the LLM MCP host. Natural language can be converted to vector, host, and MCP client, and the MCP server A, B, and C. A, access to the database A, database B, database C. This one here is outside of the agent. Internet. Through the internet, with the web API, we can collect the data. So internal data and external data can be gathered by the MCP lab, and then make a decision, political decision or agent decision by using the internal and external data together. So MCP server and the AWS, by using AWS, we can create the MCP RAG. Amazon Bedrock agent is there for the creation of the MCP server. Here the MCP server with the AWS. Microsoft provide the Playwright MCP. So same thing as the AWS, the Microsoft Playwright MCP can be used for creation of the MCP RAG as well. Azure, Microsoft Azure MCP server, they provide so that we can use all these AWS, Azure, and Microsoft Playwright for the creation of the MCP RAG. And Windows-based MCP lab can be created with this architecture. And the fast API MCP can be used for backend and MCP server with cursor. You must know the cursor. AI editor it's easy to create MCP lag by using the cursor-based MCP, and it's easy to use the MCP JSON with the API. We can access to the and get the response from the MCP server. Static data retrieval and dynamic data retrieval data in the real-time basis. Nowadays, enterprise, Japanese companies, and local government and universities uses the MCP log with the static database as well as the external real-time database to create the candidate of the candidate of the decision. When the user asks what are your free appointment next week, this one is very simple and common and easy to answer, but a more complex answer can be created with the internal and the external data getting from through the MCP lab. Such systems we use to create and together with the government, local government, and the university supervisor and the enterprise CEO. That is the current status of the fast decision making by using the predictive analytics with the internal and external data getting through the MCP lab systems. That's it. That is for the this lecture. If you have any questions, I would answer to your questions. Do you have the questions? You may use the chat. We do have another 12 minutes. I'd like to have your question from the students or lecturers or some others participants to the this lecture. I would respond to your questions. Any questions? Can you hear me?
Oh,
Good
afternoon, Professor Kohei.
Yeah.
I have one question.
Yes.
What if we don't have the word? I mean, the word is out of vocabulary. Like the word is unknown. How the neural IR can process it? Thank you.
Your question, I would like to confirm your question. You are asking the word is not included in the vocabulary. What the MCP RAG can do against the word without not within the vocabulary. Am I
Yes,
right?
yes, that's my question.
Yeah. So that you need to fine tuning. You know, MCP RAG has the plenty of vocabulary and plenty of the languages, plenty of the word. But if your word is not within the vocabulary and the MCP RAG, then you have to done the fine tuning. That means put in your word without the vocabulary, put in to the learning model. LLM has the currently nowadays the LLM large language model has the capability of the translation, the more than 180 countries languages, but some local language cannot be included in. So at that time, you need to train again, put your language, your word into a large language model and fine tuning. Then the learned model is getting more clever, understand your word, your vocabulary is expanded in the large language model. Did I make myself clear?
Yes, Professor. And what if I predict if
Mbak
I
Vivi, maaf
don't?
ini belum selesai ya kuliahnya karena kita waktunya sangat terbatas.
Oh, baik,
So
Prof.
we will go on ya. Yeah, please continue, Professor Irai. That's fine. Thank you.
Yeah, I made answer to their questions raised from the ladies, so that the fine tuning is required for the large language model. MCP host. I mentioned MCP host and MCP client and MCP server. Her question is that the vocabulary is not included in the MCP host. In that case, what she could done to include her vocabulary to the MCP host. That's why I answered that fine tuning is required for the learning large language model in the MCP host is required.
Right.
Then the MCP host can understand her vocabulary. That's my answer.
Yes, I think that's quite clear, Professor Kohei. You can continue.
Any other questions?
Java? Can you also comment on the question from Vivi a little bit? Dava, can we ask question, Dava?
I don't.
Howling.
Okay, sorry. Okay, any other question from the participant?
I want to ask, but it's not about MCP. Is it okay, Prof? It's more about RAG.
Yes, Dava is my
More about?
student in the University of Indonesia. Dava, please ask question.
Allow me to introduce myself first, Prof. Kohei. My name is Dava. I'm currently serving as a computer engineering student from in University of Indonesia, and I'm currently in my third year. I want to ask about, let's say, a RAG application to basically detect plagiarism. So currently, the state-of-the-art plagiarism checker tool is Turnitin, like, but Turnitin is a closed source, and we cannot really tell what algorithm or machine learning model that they used. And let's say if we want to make an application to basically retrieve a lot of text like poems, basically. So for context, I'm developing a platform for Prof right now. It's basically a poetry reading platform, and in the database, it consists of a lot of poems, right? But we cannot just directly basically send all of the data, all of the poems to the LLMs and tell the LLM, can you please detect any plagiarism from this poem on my database? Because it will just take up a lot of context window, right? So what I'm currently thinking of right now to solve that problem is to basically use RAG for retrieving some of the poems. And I want to know about your opinion if it's actually overkill or not for that kind of application.
I understand. What are you doing? By using the lag, you retrieve the information with the poem, and there is some context windows. By using the you already created platforms to retrieve the data by using lag. Am I right? In the machine learning model, you create the systems, but yeah, most important thing for the lag is the trained model, training data. The quality of the training data is the most influencing factor of the information retrieval. So that the if you create the learning model in the MCP lab, not the MCP, forget about the MCP lag. If you create lag, then you need to create a learning model, learned model. In that case, the quality of the training data is the most important things. So my suggestion is to check the quality of the input data for the training the model. When MCP lag and the agent AI systems are no longer merely retrieving information, but actively deciding what knowledge matters, yes. How do we design the architecture and the governance mechanisms that ensure these systems remain accountability to human values institutional goals and societal consequences. Yeah. Who made these questions through the chat? Yeah, it's very good questions. Can you, yeah, you can read the her or she, his question by using chat information.
Yes,
Yeah.
Verna. Can you introduce yourself, Verna? Or yes, please.
Vienna.
Well, yeah. Where are you from, Verna? Okay, I will read for her. When MCP RAG and agentic AI system are no longer merely retrieving information, but actively deciding what knowledge matters, how do we design architecture and governance mechanism that ensure the system remains epistemically accountable to human values, institutional goal, and societal consequences?
Yeah,
Okay.
that's it. The most difficult thing is the accountability. You know, the learning model is a black box, so that we don't know the logic in the learning model. That is the question. And the other day, I published a paper dealing with the white boxing. That means the learning model can be converted to the some sort of knowledge graph. You know, this is your answer. My answer is that create the knowledge graph. Your question is how do we design architecture? I recommend you to create long graph, not the long chain, long graph, which allow us to create the knowledge graph. Then we can we can create the accountable MCP lab. MCP lab allows us to retrieve the static data, not the dynamic data, not the real-time data. So that in addition to the long graph-based log, you would better to create the MCP. Then you can retrieve the external data, real-time data. You understand? You know, first one, long graph-based log. Would better to create. There is a one which ensure that accountable retrieval systems. Second one is the MCP. MCP allows us to access the real-time data as well as the external data, not only the internal data. That means the institutional goal and human values and societal consequences can be ensured. Can you understand? First one, long graph-based log. Second one, MCP log. Okay?
Okay. Verna, are you okay? Can you introduce yourself, Verna? Where are you from? Or you can chat if you want. Yeah. Okay, let's move on to the next question, please. Any question? Pak Yan Maraden.
Wow. Yeah. Yes,
Indra.
many thanks. Yes, thank you.
Any other question? Bu Waude, Pak Agus. Ryan?
Okay,
Wow.
maybe I have a question, Prof. Riri.
Yes, please, Pak Yan.
Okay, thank you. Okay, thank you, Professor Kohei. I have maybe a question about what is the future approach for company is going to use this platform like N8N and RAG or something like that, because it's not possible for all the company to do the training by themselves. So which direction for the students should we teach? Is it just teaching how to use RAG, or we have to teach them how to build the model by themselves, or use the pre-trained model and then train again based on the specific purpose that we want to create? I think that's the question for the student. Which direction we should teach the student in this AI AI in this AI invention, something like that.
Prof. Are.
Yeah. It's not a general purpose of the, there is no general purpose of the MCP RAG. So enterprise and the government and universities create their own MCP RAG. The most important thing is that internal data, which are in the database of the enterprise and universities and government has. So the second key issue here is the training. Artificial intelligence need the good quality of the training data set. So such a data set, firstly, we need to create. Then training model is created to become to learn the model. This is the one. And such a data is static data. Not only the static data, we need to gather the real-time data. Data may change by time. So we need to gather the new information, new data. So such organizations need to gather through the MCP. That's why I recommend you to create not only the RAG, but also MCP. In this case, MCP is a key issue to gather the real-time live data. So both static and the live data are required for the new training data set. Then you can create the new information retrieval systems. And no one asked me the cost, how much money is required for creating this MCP RAG. I respond to my question. You know, if you know the Python code and PyTorch, then you can create all the required software code by using Cursor AI editor. And CPU, we can purchase the i7, Core i7 of the PC. And that's it. No need to create the AWS. No need to Azure. No need to Microsoft. Such a systems service SaaS is required the huge cost, but we can create the one PC and software code. MCP can be downloaded from the download site, and the lang graph can be downloaded from the MCP download site freely. You can access and download and install on your computer, then create the MCP lab.
Thank you very much, Professor Reyes, because we are knowing that.
Oh yeah, another question comes up. May I ask a question for research purposes? How
Yes.
to measure level of the hallucination for lag-based LLM? What is metric? Yes. What is the minimum number of the queries that can be used in the hallucination testing dataset? Yes. It's another issue, hallucination. But there is no software tool which allow us to measure the level of the hallucination. Currently, nowadays, we are making research on how to reduce the hallucination. You know, hallucination can be measured by human, not the software tools. The minimum number of the queries, no, we cannot create such a query to avoid the hallucination text dataset. Nowadays, we don't have no such a sophisticated software tools. Hallucination have to be found by human. That's a quick answer.
Right. Thank you, Professor Kohei Array. Yes, I think hallucination currently have no way of the standardized measurement yet for just such as the normal one like latency or throughput, but for hallucination, yeah, we have to ensure that the normal and standardized measurement can be
Yeah,
implemented. Yeah.
but we do have software tools which allow us to find out the which portion of the sentences written by AI. You know?
Yes, but that's a good question. Maybe more work on that could be implemented because standards stand from this kind of questioning. Yeah. Well, ladies and gentlemen, I think we almost ran out of time, but if you have one more questions that you would like to ask, will be good.
Lily-san,
Yes,
you know the zero GTP,
zero,
GPT,
zero GPT, yes, to check, is
to
it?
check
Yes,
the which portion of the sentences are written by AI.
yes.
Sometimes I use the zero GPT for checking the student report.
Mhm.
Sometimes students make a report by using the GPT or generative AI, but I can find percentage ratio of the sentences which written by AI by using the zero GPT.
Yes.
So the most of the student report, I checked the percentage ratio by using a zero GPT, and then the 50% of the sentences are written by AI, then I return the such a report to the students.
Mm.
So it's not easy to find out the hallucination, but we can check the which portion of the sentences are written by AI. And also we can find the which moving picture is faked moving picture. Such a AI generated moving picture, AI generated picture, image, AI generated sentences, we can find by using AI. Made clear?
Yes. Okay, ladies and gentlemen, it's quite a number of people I know and I don't know because some of them also being distributed by the department, and there are some new students also from our master program.
Mhm.
Yes, is there any other question to Professor Kohei Array? Okay. Jauzak, any question? Or Pak Agus?
Wow. We do have the 74 participants.
Yes.
Mm.
They're all really interested in this because this semester implementing agentic AI is something that is very common now.
Yeah, yeah.
The problem is that we know that now to create our own data set is something that is a big problem, also costing a lot, and also to
Mhm.
maintain
Mhm.
that. Yeah. Any other question, Pak Andri Saputra, or anyone? Bu Wina mau nanya, Bu Wina Widiati, dari mana Ibu? Silakan. No? Oke. Fala, silakan Fala. Pak Supriyatna? Okay, Professor Are,
Yeah.
knowing that you are using a zero GPT to check, do you going back to the normal examination way in which everyone have to write down the answers and the old way of examination, like
Yeah.
yeah.
Mhm.
Yeah, what do you foresee to the future? Our education system will be shaped by this AI.
Yeah. Remarkably change in the near future. One of the subjects to teach is metaverse and AI avatar teach students the most sophisticated current topics and future topics we create beyond our idea that AI avatar create and recommend us. And such a contents would be a good lecture materials in the metaverse world. We can share such a content among the participants or students.
Yes, it's
That's my goal.
Yes, yes. I know that we have to train ourselves also to make decisions on the best answer that could be provided, because uh, the the skills that we have to learn, I think, is questioning how we can structure the question structurally and hierarchically, and also knowing the strategic aim of the questions. So questioning is number one skill that must be mastered, I think. Yeah.
Yeah. Why don't we collaborate for creation of the future educational systems or some other topics, research topics? There are so many research topics in the AI area.
Yes, interesting. We can move on later with the via offline, Professor Ray, because we know that you are the one who introduced our early 20 years ago with LMS, and now it's widely used in Indonesia. Everyone using a lot of IT support, and even during the pandemic situation, things are quite okay, and the learning loss is not as bad as it was expected to be, because everyone can adapt. Hopefully, I think during this transition to the AI-based system, we will build up skills and knowledge in which the students can eventually later on direct the next development of what human being can be depending on. For example, we know that now at the Universitas Indonesia, we're also trying to make sure that empathy and maternal instinct can be put into the guardrails that can be learned by the AI system in the future, so that they will help us not to destroy the humanity.
Oh, yeah.
Mhm.
Yeah, same direction and the same goals.
Yes.
So we can collaborate.
Sure, yes.
Yeah.
Okay, is it your last slide? Because we are almost 120 minutes by now.
Oh, yeah.
Do you want to finish up your slides? Because it's still services at the moment.
You know, the another 30 slide I do have. So I don't have enough time to cover all the materials, presentation materials. The rest of this slide describes the future MCP lab, long chain, long graph based MCP lab. So that's fine. Next time, I will show you.
Okay, so I think because it's already almost 2 hours together, I'm very
Mm.
happy to know that more than 70, 80 students were here, and also some researcher in AI area were here. I'm very happy to meet you again, Professor Array, because we learned from you a lot that you've been catching up all the time very quickly without any hesitate to share your new findings and learning that it's not easy to keep up all the time all these years, but you are a great example of how we can have entitled to long life learning. So we are very delighted to have you with us, and maybe if you would like to have a closing remarks, that will be very good, Professor Array. Before I will show you a certificate from our department to thank you for your time today to share and your willingness to uh, patiently start from NLP, back of words, and all the old way of seeing this to chatting with and also eventually have the MCP and RAG to be able to use the agentic AI to help us to connect, just like USB, putting us to connecting it to the real world.
Mhm.
Yes.
Finally, I would like to thank all of the participants for your participation, and you gave us some good questions to me. So I do hope the near future we can collaborate with some research work between the participants and in the near future, the new findings will be updated and present if I have some chance to talk about. I look forward to talking with you. Thank you again. Thank you for your participation.
Right.
That's it.
I just want to show our certificate of appreciation. This
Wow,
presented
great.
Professor Kohei from Saga
Yep.
Japan for sharing his valuable knowledge today at the Electrical Engineering Department, Faculty of Engineering, University of Indonesia, and other guests who have witnessed how you have show us that you are always keep up with the latest development. Thank you so much for the great example, Professor Array, because I know you more than 21 years and you're still always young, you know. That's amazing.
Okay.
Yeah, I would like to invite everyone to take picture if you would like to open your video so that we all can be just like Professor Array, knowing what next to do for the humanity, to help each other to learn, and also to benefit the society at large.
Mhm.
Once again, if you would like to open your video, we will take some video, some photos. Dapat silakan.
All right, Prof.
I see you now, Professor Kohei. Thank you so much. Not much different from 21 years ago.
Let's
Amazing.
take a group photo.
Yes, group photo.
Yeah.
Right. Open, everyone. Yes, I'm very happy that you are all here. Semua buka kamera ya, supaya bisa yang nggak hadir di korting nilainya. Okay. Okay, very good. Yes. So Professor Array, maybe we will see new things that we can do together. I will also let you know what new things that we can build up. Like here, we have a lot of human resources that is really interested in new technology. So we are all open and we are all ready because we just distributed this call, but many people come from many places. And because it's the end of the year, we wish you a wonderful holiday season and wish you a wonderful and new year to come. Right. Sudah foto semua? 1, 2, 3. Each knee stand.
Wow.
Right. Thank you, Professor Arai. My best regard to all, everyone in the University of Saga and from all of us. Thank you again.
You are always welcome.
Terima kasih.
Terima kasih.
Yeah, and we'll see you in the next meeting with new professors and other opportunities. Thank
Yeah.
you. Bye.
Bye for now.
Thank you.
Thank you. Terima kasih.
Terima kasih.
Profesor.